Record. We discussed the reactions of haloalkanes, and we said there are two reactions of haloalkanes. There are the haloalkanes undergo two type of reactions, right? वो two type of reactions क्या थे? वो two type of reactions थे. एक था the most or major or most of the reactions were nucleophilic substitution, जिसको हमने क्या sign दिया था? SN. And the second type was elimination. And now today we are proceeding on, and we have to see what is the mechanism for the nucleophilic substitution. Elimination do not have in our syllabus the mechanism of elimination, but nucleophilic substitution we have to discuss how the mechanism takes place, right? So today we are going to discuss this mechanism. So please write down nucleophilic substitution reaction of haloalkane. Nucleophilic substitution reaction. Okay, so nucleophilic substitution reaction, we call it SN, substitution nucleophile, not NS, okay? SN. Now, if I give you an example, for example, yeah, this is a haloalkane reaction. Look at this haloalkane, bacho. This is 2-chloro, 2-methyl propane, right? It's an haloalkane. It is 2-chloro, 2-methyl propane. When it reacts with NaOH aqueous, OH negative aqueous is the nucleophile. Right? So OH negative is nucleophile. So what we said that the OH will come and take the place of Cl. As a result, the product is C CH3 and then OH plus NaCl. So the nucleophile of sodium hydroxide aqueous, which is OH negative, that comes and take the place of Cl. Okay, this is what we learned in the last class. And I told you, I always tell you this thing, reaction tells us what happened. And the mechanism tells us how it happened, right? We can simply say in the reaction, okay, here was CCl, and now there is here COH. But how CCl bond was broken, how COH bond was formed, the all details, they are present in the mechanism. So if you look at the mechanism for this reaction, it's a two-step. It's a two-step. In the first step, the leaving group, the Cl, has to leave. Okay? So in the first step, this CCl bond breaks and Cl leaves. I hope you know what is this side partial negative, this side partial positive. So I hope you know what is the what type of bond breakage is going to happen? Homo or hetero? When there is electronegativity difference, we know the heterolytic fission takes place. The more electronegative takes the pair along. So which one is more electronegative in this case? Cl. So and the homolytic heterolytic fission is shown by full-headed curly arrow, showing कौन सा electron लेके जा रहा है. And as a result, two products form. One is this positive and the other one is negative. And positive is electrophile, negative is nucleophile. But in carbon case, when carbon gets a positive charge, we call it, yes, carbocation. But as soon as we talk about carbocation, the one thing that comes in our minds is its stability. आप कहते हैं जी ये तो stable ही नहीं होते. They are not stable, the carbocations. But immediately when I look at this carbocation closely, I can figure out that how many alkyl groups attached. So it means this carbocation is tertiary and the stable. And why stable? Because there are 3 alkyl groups giving enough positive inductive effect to stabilize for a while, because the OH is going to come and approach this carbocation soon, but in the meanwhile it has to stay. Okay, so आप कहते हैं yes, carbocation formed is a tertiary carbocation, right? So you have to explain to the examiners how they can stabilize 3 alkyl groups attached. A lot of positive inductive effect. A lot of positive inductive effects. Give stability. To carbocation. Okay, now here it is. Sorry? Yeah, you are not supposed to draw. I'm just explaining it that all alkyl groups pass their electrons towards carbocation. Usse uska positive charge is kind of reduced or dispersed, right? So hence gives the stability. But as I said, this is not for you. This is for explanation only. Okay. Now in the second step, I can draw the carbocation down here again, but I'm gonna give the shortcut to this. So instead of this, I'm gonna write Cl negative on the top. And in the second step now, OH negative comes in with its lone pair of electron, and curly arrow means there is going to be a dative bond formed between oxygen and carbon in the second step. This is the second step. This is the first step, which I write in Roman number 1. That is the first step. And again, here it is the second step. So this CH3, 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 and what is formed here? OH. So in simple words, you can understand the mechanism is 2-step. In the first step, the leaving group leaves, the Cl goes up, and in the second step, the OH comes and takes the place. So it's a straightforward, but the explanation that how after departure of the Cl, how it is stabilized because of 3 alkyl groups with the carbon giving a positive inductive effect, right? And this mechanism is known as SN1, unimolecular nucleophilic substitution. The mechanism is named as unimolecular. Sorry? Yeah, NaCl is the other product, but at this moment I just represented how Cl left and turned into Cl negative, right? So this is known as unimolecular nucleophilic substitution. Unimolecular nucleophilic substitution reaction. Now, overall, the mechanism is named as not nucleophilic substitution, precisely unimolecular nucleophilic substitution. Unimolecular nucleophilic substitution, SN1. SN1. Okay? Or it only happens, now I'll come to this point. It only happens when a haloalkane is tertiary. because then it would be able to generate a stable carbocation, right? So please write down with the star. SN1 happens or followed by only tertiary carbocations, tertiary haloalkanes, right? Secondary, at times they can undergo because they give stability, but depends on some certain factors जो हमें discuss नहीं करने, right? So secondary may undergo, but they are not the part of our syllabus. What are the factors which we will have to increase to give this? So secondary, I'll explain in the next part. Just give me a minute. Secondary haloalkanes may undergo SN1. Now, please, can you ask your question again? Say it again, question. SN1 followed by tertiary haloalkanes only? Yeah, just give me 2 minutes. Okay, so okay, now another example which I'm going to give you. Please look at this. इधर देखिए, for example, please pay attention. If I have this haloalkane, CH3, CH2Cl plus NaOH aqueous. Again, OH negative is the nucleophile. Again, heat and the reflux. What is the product now? Anyone? What is the product? Cl will come and take the place of? Along with NaCl. If you look at the mechanism again, so you must be thinking the same, that is going to be two-step. In the first step, leaving group leaves, and the second step comes in, the OH negative, but actually it's not. Why it's not? Now listen. There's the answer to your question as well. Please pay attention. If you look at this haloalkane, this is 2-chloro. This is 2-chloroethane. Chloroethane. Okay. Now, if you look at this, please pay attention. It is like this. Let's say it's following the same mechanism. ये आपने नहीं लिखना. You are not supposed to write. Please stop writing. Let's say it's following the same mechanism as it was. In the first step, Cl leaves. Hydrolytic fission takes place. Here, what is the product formed? Carbocation. Please do not write this. But this carbocation is what type of carbocation? Which are highly unstable. आप कहते हैं this is not possible in this case. In this case, when a haloalkane is a primary haloalkane and it is going to generate a primary carbocation, so this is not possible that the Cl leaves in the first step because carbocation cannot exist. This is the thing which cannot exist, right? So in this case, SN1 mechanism, the mechanism that was happening in 2 steps, the mechanism in which the leaving group leaves, I mean the Cl or haloalkane, halogen, and then left the carbocation, and in the second step, the nucleophile comes and takes the place with that carbocation. That's not possible. So what happens in this type of reaction when the haloalkane is not tertiary? So that is not possible. So in this case, there's another thing that happens. In this case, the OH negative, the one that has to substitute the Cl, the nucleophile, that comes and provokes the carbon, right? And this leaving and incoming group, that thing takes place simultaneously. Because as the carbocation cannot exist, so it's just like, for the sake of analogy, I'm saying, just imagine there is a chair. Anashia is sitting on this chair. Azka has to replace her. So there are two situations. Situation one, the SN1, which we did. Excuse me. Anashia leaves in the first step and leaves the chair is empty. Azka comes and sits here. That was SN1. But in SN2, the situation is now different. She can't leave the chair. It's going to be unstable. So we can ask Azka, it's just for the sake of analogy, okay? We can ask Azka to come and sit here with Anashia, slowly, steadily pushing her. Finally, I'm using right words because it's been recorded. So DJ gira de usko. So I hope you are getting what I'm trying to say. Okay, the leaving group and the incoming, that takes place simultaneously. As much space she leaves, the same amount of the space she is acquiring. So are you getting? So same thing happens here. I'm going to share my screen. The same thing happens here, that the OH negative is the one that comes in and actually, I'm using the word, provokes the carbon to accept the electron pair. And the bond formation with the OH, now in a technical term, not in analogy terms. Now, what I'm trying to say, that in technical terms, this OH is trying to build up a bond with this carbon, and simultaneously, the carbon is, yes, breaking the bond with this Cl. So this process of making the bond and breaking the bond takes place simultaneously, right? And then in the final product, there's no intermediate in this case. There is no intermediate because we have decided, we have seen that carbocation, the primary that was supposed to be the intermediate, is impossible to exist. So therefore, so there is no intermediate as OH comes in and making a bond with Cl. So as the bond strengthening taking place between carbon and oxygen, simultaneously the bond weakening between carbon and chlorine is also taking place, right? And final, the end product. So I'm going to write the end product here. The end product, there is no intermediate, okay? The end product is like this. OH is here, okay? And this is H, this is H. Please don't write it. This is. So in technical term, it's a one-step mechanism in which the OH comes and takes the place of Cl. So the process of bond making and bond breaking is taking place in simultaneously in the same step. As the bond between carbon and oxygen is strengthening, the bond between carbon and chlorine is being weak. But as I said previously, in mechanism, in organic mechanism, we cannot say all these words in, all these things in words. So for that matter, the reaction is only one step. Mechanism is only one step, right? So there is no step, there is no intermediate. But what we do, instead of saying all these things in words, that OH bond is strengthening, CCl bond is weakening, both of these processes taking place simultaneously, we just draw this diagram. Now look at this diagram. We draw it like this. There is a hydrogen, there is a hydrogen, there is CH3. And instead of showing a full bond with the dotted line, we write Cl here. And with the dotted line, we write OH here. So at this moment, we can see carbon is making 1, 2, 3, 4, 5 bonds. Actually, it's not. So these two bonds, this dotted line and this dotted line, is actually showing the thing which we said in words. Okay, now at this moment, this bond, kya ho raha hai? Bond weakening or breaking. And what about this? Yes. So again, I will explain. I'll clarify. It's not an intermediate because students usually get confused. Isme bhi they show the intermediate. This is not the intermediate. This is what our thinking, which we put it on the paper. This is actually happening. And instead of saying in words, we just showing it like this. So this is bond strengthening. And this is what? Bond weakening. This is bond weakening and this is bond strengthening, right? So this takes place. This is known as transition state. You don't call it intermediate. This is a transition state. In other words, if somebody asks you, or for your own understanding, what is the transition state? It's just our imagination, which we put it on the paper, right? To explain somebody how this bond take place. So whenever they ask you to write, now please, again, whenever they ask you to write the mechanism, you just have to write this thing only. It's a one-step mechanism. OH comes, attacks the carbon, provokes the carbon to make a bond. Bond making, bond strengthening takes place in one step, and finally the product along with Cl negative here is formed. That's it. But yeah, when at times in MCQs or in a structured question, at times they ask you, okay, fine, what is the pentavalent? Penta means 5, where the carbon is making 5 bonds. Okay, pentavalent transition state. So you say, oh, we know what is a pentavalent transition. It's just an imagination, which we put it on the paper to explain how the bond formation and bond weakening take place, right? Just to show that these are happening in one step. All this thing is happening in one step. So you call it a transition. I hope it's clear now. Okay, when they ask you to draw, you are not supposed to, when they ask you to write the mechanism, the only thing which I have in box, you have to write that thing. But they ask you to explain what is a transition state, then you have to put this diagram which I have just shown here with the dotted line showing that OH is coming in and CH is leaving, right? Okay, and this happens, and this mechanism is taking place in yes, primary haloalkanes. So now what I said, now I hope you understood. For the tertiary, as their carbocation can stabilize, so they go by that mechanism which we did before, SN1. कि Cl चला जाता है और OH आ जाता है. In the primary, as it's not possible कि Cl चला जाए और फिर बाद में OH आए, so the process takes place simultaneously. Or in secondary, ऊपर मैंने बता दिया, both mechanism can take place, right? Secondary में क्योंकि दो alkyl groups होते हैं, at times their carbocation can stabilize, therefore they follow the SN1. If their carbocation cannot stabilize, they follow SN2. This is called SN2, right? Bimolecular mean, now let me come to this point, right? पहले इसको लिख लें, फिर मैं ये bimolecular, unimolecular explain करता हूँ. This mechanism is known as, जी ड्रॉ कर लें, मैं एक्सप्लेन कर रहा हूं इसको. This mechanism is known as bimolecular nucleophilic substitution. This mechanism is known as SN2. So 2 matlab bimolecular and mean nucleophilic, S means substitution. So bimolecular nucleophilic substitution. Yes. Or primary, all primary haloalkanes follow SN2. Primary haloalkanes follow SN2. Reason I have told you, because their carbocations cannot stabilize, right? So मैंने तो याद ऐसे रखा हुआ है कि जिसमें 2 आता है ना वो 1 step है और जिसमें 1 आता है वो 2 step है, because it's not related to the steps actually, right? So it's a 1 step mechanism. It's a one-step mechanism. So now why you call it SN1 and SN2? Now let me explain this. If it's not related to the steps, pay attention, pay attention. So just for 1 minute, pay attention everyone. Now, coming back to the analogy which we made in order to understand, may not be very pleasant, but unfortunately. So now if SN1 में क्या हुआ? Anastasia leaves on her own, right? On her sole decision to do that, right? There was no scuffle or anything. On the other hand, in SN2, so चलने पहले SN1 clear. It means it's the Anastasia who decides when she's going to leave this chair alone. So that depends the reaction speed. Then in how much time the substitution will take place depends entirely on the Anastasia. So in a SN1, if you're coming back to the SN1, when the leaving group leaves and the incoming OH negative is always ready to come in. So it depends on the strength or the concentration of haloalkane only, because they have to leave their Cl. On the other hand, in the SN2, what happens? Azka has to come, take a very small place on this chair, and then start pushing Anastasia out of the chair. So it matters how much strength Azka have and how much strength or resistance Anastasia can give. So therefore, in SN2 mechanism, both the OH negative concentration and the haloalkane concentration matters, right? Because they are the ones, because OH is the one that comes and push the Cl out. So I hope you got my point, what I'm trying to say. So it means that's why you call it SN2. SN2 means both molecules involved in the rate of reaction. Okay? Both molecules determine the rate of reaction. In SN1, only haloalkane determines the rate of the reaction. So 1 and 2 is not with the steps. 1 and 2 is with who determines the rate of reaction. Who can influence the rate of reaction. In the second mechanism, both the haloalkane concentration and the reactant, the OH negative concentration. If you OH negative concentration increase karoge, obviously there'll be more OH negative ions. They'll be pushing all the carbon together, making CCl bond weaker quickly. So rate will go up. But on the other hand, if you even increase the concentration in SN1, if you increase the concentration of hydroxide ion, it's not going to affect, because the CCl bond that was broken in SN1 has nothing to do with the OH concentration. Got it now? So that's why please go up and write in SN1 the rate of reaction, the rate or speed of reaction. In SN1, please, rate or the speed of reaction depends on the concentration of hydroxide ions only. Oh, sorry, haloalkane only. Hence, unimolecular nucleophilic substitution, we call it. Uni mean one, unimolecular mean one molecule. Okay? As in SN1, the rate or the speed of the reaction depends on only concentration of haloalkane. So that's why we call it unimolecular. On the other hand, अब इसी के opposite क्या लिखेंगे? In SN2, both the concentration of haloalkane and the concentration of yes. So that's why we call it bimolecular. So uni and bimolecular is related to the rate or speed, not related to the steps. Okay. So in the second part, you will write SN1 का था ऊपर. Abhi now I'm going to write for SN2. The rate or speed of reaction depends on the concentrations of both. Haloalkanes and both haloalkanes and hydroxide ions, the nucleophile, or NaOH, in other words. Right. So when they ask you to draw, you know what you have to draw when they ask you in SN1. And they ask you what is transition, pentavalent transition state, what is it explaining, you know what you draw. Okay. And what it explains, वो भी मैंने आपको बता दिया. Or in tertiary, it goes like the same. Okay. That leaving group leaves and the incoming group comes in the second step. Now I'm going to give you 4 examples in which you have to write the mechanism. Okay. That's your homework. And in all these 4 examples, if there is, now listen everyone, if there is a primary, you will follow SN2. If it's a tertiary, you will follow SN1 when you are writing the mechanisms. And if it's a secondary, now it's solely your decision, okay? Because the factors which derive actually, which decide which secondary is going to follow, they are not in the part of the syllabus. So therefore, I leave it to you, okay? Whatever you like, you can follow that, okay? So example number 1, it is 2-bromo, 2-methyl, butane reacts SN negative. Number 2, iodo, NaCN. NaCN, ethanolic, and heat under reflux. 2-iodo, propane. Mechanisms. पहले reaction और फिर you have to write the reactions and mechanism for all these reactions. 2-iodo, propane reacts with KOH aqueous, 1-chloro-butane reacts with NaOH aqueous, or 2-bromo-butane reacts with KOH aqueous. Okay, you have to write these 3 reactions and their mechanisms, and you have to decide which type of mechanism you are going to follow. Picture group पे 1 मिनट है जी. इसकी picture लेके please group पे डाल दें. Okay, that's all from my side. Thank you.